Now, let's talk about graph and graph traversals in C++. Before we start coding, let's understand the concepts of graphs and graph traversals. A graph consists of nodes, or vertices, and edges that connect these nodes. Graph traversals help us explore and analyze the connectivity within a graph. Two common graph traversal algorithms are depth first search, DFS, and breadth first search, BFS. Let's begin by implementing a graph in C++. In this code snippet, we include the IOStream and vector header files. The vector header file provides a dynamic array-like container which we'll use to represent our graph's adjacency list. Next, we define a class called graph. Inside the class, we have a private member variable numVertices to store the number of vertices in the graph. We also have an std vector called adjacency list to represent the graph's adjacency list. The graph constructor takes the number of vertices as an argument and resizes the adjacency list vector accordingly. To add an edge between two vertices, we use the addEdge function. In this example, we add edges between various vertices by updating the adjacency list accordingly. To print the graph, we use the printGraph function. It iterates through each vertex and its neighbors in the adjacency list, outputting the vertex and its adjacent vertices. Now, let's move on to graph traversals using the depth first search and breadth first search BFS algorithms. And this code will be pasted in the description so you can follow along on Replit or your IDE of choice. In this code, we continue with the graph class definition and the necessary header inclusions. We define two member functions, depth first search and breadth first search. The depth first search function performs depth first search traversal. It uses a stack to keep track of the vertices to visit. We initialize a Boolean vector visited to keep track of visited vertices starting from the specified start vertex. We push it onto the stack, mark it as visited, and continue until the stack is empty. In each iteration, we pop a vertex from the stack, output its value, and push its unvisited neighbors onto the stack. The breadth first search, or BFS, function performs BFS traversal. It uses a queue instead of a stack. Starting from the specified start vertex, we first enqueue it, mark it as visited, and then continue until the queue is empty. In each iteration, we dequeue a vertex from the queue, output its value, and enqueue its unvisited neighbors. In the main function, after creating the graph and adding edges, we demonstrate graph traversal using both DFS and BFS algorithms. We output the visited vertices during the traversal.